increases until I get to 10. And if you don't know how to do this, it's very simple. You do 10 divided by 4, 2.5. And you can confirm if that's true by writing it in. If this is 2.5, that means that this is 5, this is 7.5, and this is 10. It makes sense. It is going up by 2.5. So if you've never figured out how to figure out a scale when you're given one, because usually you're always going up by ones or twos, it's very easy, right? But when you have something difficult like this, maybe some of you have never seen this before, this is how you do it. You take the first known value given, and then you count how many sections were there before that, equal sections. So 1, 2, 3, 4, 4 square boxes. So then you do 10 divided by 4 equal boxes, and you get 2.5, and then you're going up by that amount. So why did I do that? Well, I know how much I'm going up by now. I know I'm going up by 2.5. So if this is 20, then this value here is going to be 22.5. Right? Now we got to figure out when's the next repeating value. If I go from here to here, is this the next repeating value? And the answer is no, that is not the next repeating value, because that's only half of the function, half of the cycle. You got to keep going until you get to this point here. And now we know that the next repeating value is right at this point here. So from here to here. So this is 22.5. This is 12.5. So, and the difference between 22.5 and 12.5, you guessed it, is 10 seconds. So the period is once again 10 seconds. And remember, the period shouldn't be changing. This just proves to us that we're doing it right. So those are 3 different ways. I'm going to teach you one more way, which will become useful later on in the word problems. And I really wish I was able to do a word problem with you, but unfortunately, we don't have time. So the word problem would most likely give you not even a full graph, not even a full cycle. They'll only give you half a cycle. They'll only give you a cycle, let's say from a maximum to a minimum. That's it. They will only give you this much. But guess what? That's enough for me to solve the whole thing. Because they gave us the maximum value, which we can use to solve for a C. They gave us the minimum value, which we use to solve for C and A. So if the word problem gives you the maximum and minimum value, guess what? Use these 2 equations to figure out for C and A. The tricky part is now the period. They didn't give you a full cycle. So how do you figure out a period if you don't have a full cycle? Well, you use the knowledge that I'm going to give you right now. And that is the distance from a maximum to a minimum is exactly half a period. This is exactly half a cycle. And you can see that this is half and then this is half. It's exactly half. And what does that mean? Well, if I know the time from the maximum, which is 20 here, to the minimum, which here, in case you can't see because I've blocked it out, it's two dashes away. So 22.5, 25. So this is 25. So distance from here to here is 20 to 25. You subtract them to get the difference. It's 5 seconds. So 5 seconds is exactly half the period. That means all I need to do is times it by 2, and I'll get 10 seconds. That means the full period is 10 seconds. So I did a lot of stuff here in this one example, even though it didn't ask you, because I told you I'm trying to teach you for the future examples that you will get. All right. So the distance from exactly a maximum to a minimum or a minimum to a maximum is exactly half a period. Once you figure that out, you know that you just have to multiply it by 2, just double it, and then that is your full period. So in this example, we have 10 seconds as our period. What do we do with that knowledge? Well, remember, there's an equation for k is equal to 360 divided by period. And since period is 10, k is equal to 360 divided by 10. K is equal to 36. I have now solved for my A value. I have now solved for my C value. And I have solved for my K value. I have solved for 3 out of the 4 transformation values. And these are the easiest three. And you can get like 80% of the marks by just doing these three. D is a little bit more difficult. It's a lot more difficult, actually. It's very confusing. But let's do it. At this point, you have to write your equation. What is my equation going to be? Well, I know my equation is going to be a sinusoidal function. What do I mean by sinusoidal? It means it's going to look like y equals sine x or y equals cos x. So if I'm writing it in terms of sine x, my a value is 2 sine, my k value is 36, bracket x minus d, and then my c value is plus 1. So this is my equation. The only thing is missing is the d value. Or my equation can be y equals 2 cos bracket 36 x minus d plus 1. Both of these can be my equations. So when it comes to sinusoidal functions, your paired functions can be both sine or cosine, and it clearly tells you determine the equation of a sine and a cosine function. So be very careful. For this unit, the question might ask you to give me two equations, two parent function equations, or two transformed equations, but one being a sine x and one being a cos x. The only difference between the two, though, they're going to look exactly the same. The only difference is their d value. And I'm going to teach you how to do the d value right now. I'm going to erase this since you've already... This is recorded, so you can definitely just go back and take a picture or pause it or whatever. We are going over time, but that's fine. I need to teach you this. So my d value, how do I figure out d value? Well, we compare this to our parent function. Y equals cos x. Does anyone remember y equals cos x? What's the first point that y equals cos x starts off with? Does it start off at a maximum point? Does it start off at a middle point? Does it start off at a minimum point? And let's take a look. We have y equals cos x. That's sine x. Here's cos x. The very first point starts at a maximum. Why is that important? Well, look at our very first point here for this function. It starts at a maximum. What does that tell me? Well, that tells me that for y equals cos x, there is no phase shift left or right, because by definition, this function is starting at a maximum point. And since y equals cos x starts at a maximum point, my d value for my cos function, my d cos, is going to be 0. There is no phase shift because it didn't move left or right. It actually stayed put. It stayed the same. So my d cos is 0 degrees. So in this example, my d value is just going to become 0. So it's just going to be like that. What? 2 cos bracket 36x plus 1. There's no need for a double bracket because there's no d value. Okay, that was d cos. And d cos is very easy to do when your function starts at a maximum. What about d sine? Because clearly this is starting at a maximum, and my d sine starts at a... Look at the point the d sine starts at. D sine starts at a middle point. Middle point. I like to call this a node, but you can call it whatever you want. Middle point, node. So my sine function normally starts here at the center point, node. So you have to now find a point on this graph that is a center point. Well, my center points are pretty straightforward. You can clearly see. It's right here. That's my center point, right? And right here, and right here. So we have to look for our nearest center point. My nearest center point is going to be this one here. But now the question is, this point right here, is this the beginning of a sine curve? Is this the beginning of a sine curve? Does the sine curve go down towards a minimum point? And if you look at our sine function here, our sine function starts at a middle point, but it's not going down. It's actually going up to a maximum, and then it goes down. So our sine function starts from a middle point that's going up. So if you go back to our middle point here, the very first middle point is going down. So this is not the start of a sine curve, sine x. This is like somewhere in the middle. So we have to go to our next middle point and see if this is the start of a sine curve. And yes, this middle point does go up to a maximum point and does go down and completes a perfect sine function. So we are going to now transform. We're going to shift from our blue point to this red point. So our initial point is always our blue point. Our starting value is always on the x-axis, or rather y-axis, sorry. And we know that the parent function starts at the blue, and now this function has been shifted to the right. By how many units has it been shifted to the right? It's shifted right by exactly this many units. Well, we don't know what value that is. Well, yes, we do. Because remember, I figured out that it's going up by 2.5s each time. So 2.5, 5, 7.5. So my d sine equals positive 7.5 because it's a shift right by 7.5 because it's shift right. So it's 7.5. So my value inside here is going to be minus 7.5. Because that's how the equation is, right? And that's how you solve for an equation when it comes to, given a graph and finding an equation and finding both the cos and sine. And yeah, that's it. Time's up, guys. Fortunately, I can't do more.